Today we're going to have a short session and create an AWS Lambda, and we'll talk a little bit about serverless before that. But I'm going to start with a blank sheet of paper today, and we're going to do a quick walkthrough, and we're going to build one together. So this is going to be fun. Our agenda looks like this. Why serverless? Then we're going to go through a high-level diagram of what we're going to build in a very quick time frame. Then we're going to do the actual building of it with a hands-on walkthrough, and then we'll wrap it up and finish with any Q&A after that. So I don't think it's going to take the full 40 minutes. It's a very basic example, although very useful in my opinion, but we'll see how long it takes us. Why serverless? Serverless is a topic that I feel pretty passionate about. I've been using containers and public cloud since 2010, and when serverless came on the scene, a little bit after that, AWS was the pioneer in this architecture. They decided to take away a lot of these complexities that people are having with implementation options for their applications, and so they're like, hey, we'll handle the operations for this. We'll handle the auto scaling. And the bottom line is it's going to be simpler and it's going to be a faster time to development for you and your dev team. And so I was an early adopter and became a fan a long time ago. And you'll see why here in a little bit. My serverless experience, I think most of you know I worked at EA for over a decade. All game services for multiple EA titles that I worked on were implemented via Lambda in AWS. And so it's kind of surprising to a lot of people that you buy a game off the shelf at Target or Best Buy and you plug it into your Xbox. But the fact is that all of the central services, things like leaderboards, guilds, online chat, the in-game store, microtransactions. We had about, I think, 275 microservices / lambdas that managed everything about the game except the actual gameplay. So when you're shooting bad guys, you're running around the world, that's obviously, C++, tethered to game servers type thing. But everything else that was more about your account or web or mobile or platform related type things, those were all done in Lambdas. What workloads are candidates for serverless? Number one, microservices. I think many of you attended one of the talks that I did a few months ago that was based on microservices. Perfect scenario is that Lambda is a first candidate to implement a microservice. The second one is they run in less than 15 minutes. This is a cloud provider restriction with Lambdas, and I think Azure and Google have a similar one, although I'm not sure if the times are exactly the same. But I don't know about you, but in my career, I can't think of many things that an actual execution took longer than 15 minutes. So yeah, that'd be pretty rare. Maybe some machine learning or big data jobs on Hadoop or Spark or something like that wouldn't be a candidate. But if it runs in less than 15 minutes, it is. Event-based. So maybe it's you want something to fire when there's a row in a database, or a record in a queue, or a push button on an IoT device. These are perfect scenarios to launch or execute a Lambda. And then the last one I have here is when it's not executed a gazillion times. Keep in mind that a serverless approach, or Lambdas in particular, it's a metered based pricing, so you pay per execution. And while you tend to get a little bit concerned about that, I mean, it's so marginal in nature that a couple million executions is like, I don't know, $1. So that's fine, unless you have something that gets like, billions of events per day. Now you're talking like you have a pretty big bill as a result of that. So you would rather do something with containers on EC2 or something like that. So You don't want a pay per execution if it's executed that frequently. But the summary here is, in my opinion, the far vast majority of workloads are candidates for serverless implementation. Event integrations. These are the things that you tie into and you launch. So this is from the AWS console. API gateway here, upper left, that's the one we're going to do today. So basically create a public endpoint that is going to launch our AWS Lambda. But the cool thing is they have so many different integrations with all the different components in AWS, whether or not it's databases or notification systems or MQ, S3 buckets, SQS, which is queuing technology. Anything that you would want to stitch together to launch your code, they have a way to do that. I didn't do a full screenshot of the partner event sources, but really robust offering there. Everything from Slack, Splunk, things like that. When an event comes through, you could either go to Slack or from Slack, bidirectional. Really, really robust capabilities that you have to integrate your Lambdas with these events. Okay, here's what we're going to build. Here is the exercise at a high level. On my laptop, we are going to submit a REST payload to an internet endpoint, and we're going to get a JSON payload back. The example we're going to use is NOAA, which is a national weather forecast, and we're going to query to get a few attributes from them. And the one we're going to ask for is water level for the particular area that I'm in. Now, the data itself, nobody really cares, but the most important part is we're going to reach out. We're going to hit a public endpoint on the internet. We're going to get a JSON response back, and we're going to show the results. That's the first thing we're going to do. We're going to show it working straight from my PC to the internet. Then we're going to do our AWS part. So everything is going to be very similar, except we're going to contact an API that AWS is going to generate for us, which is going to be a public endpoint. That's going to call our Lambda code. And then inside that Lambda code, which you'll see, is going to be code that reaches out and makes that same internet endpoint request to the NOAA service. It's going to get it back, send it back through the gateway, and then back to my PC. So very simple example. I mean, there's a lot of them that we could have done, but I thought this one was good because it also includes the API gateway, which a lot of the applications we're going to be building nowadays are going to have API gateway, where a front end, either a web app or a mobile app, is going to hit an endpoint. It's going to request account information or create a new account or save data or retrieve data. Very, very common thing to use the API gateway. So I wanted to use that in an example. Here's the order we're going to do it. We're going to create the Lambda, then we're going to create the API gateway, and then we're going to submit the request from my PC, and hopefully it'll all work. So I practiced a few times today. It worked fine then. We'll see. Nothing like showtime, right? All right, a few Lambda specifics. For those of you not familiar with it, the entry point for the Lambda is in this function called Lambda handler, and passing in is the event and context. And there's a lot of material on the web that gives you really descriptive information about what each one of those are. The bottom line here is that event is going to have in it all the data that is passed in the body of the call. And so, or in the case of a GET call, it's going to be query parameters, right? So that is where you handle them. And then context is the context of the call. Not important for this discussion, but everything with a Lambda starts with its entry point, which is this guy here. Now, once you're in here, you'll see in my code that you can call functions that exist outside of this, and they call other functions, and you can do whatever you want. But the place that Lambda launches is in the Lambda handler. The other thing is my example is going to be using Python. You can do anything Python can do in there. but there are certain libraries or on imports that they might not have. And so for this one, I used requests, and the basic default Lambda for Python did not have that module loaded. So what I had to do, you'll see here, is I had to download a zip file of the requests module, and I just included that in the zip file that I uploaded. So basically, they spin up a VM in a container with a Python environment, and sometimes it'll have those things that you need, but it doesn't always. So in this case, it did not have the request module, which I'm using to do my call out. And so I just included that in the code that you'll see. Okay, let's go through the walkthrough. I am going to switch over. I am in the AWS Management Console here, and I'm going to go to Lambda. We're going to do the Lambda first. The first thing I'm going to do is over here in the upper right is I'm going to create a function. Now, this walkthrough we're doing today, I'm doing everything in the console. There is no problem with CI/CD and doing robust pipelines and not doing it through the console. But for like first timers and just the learning thing, I always like doing it through the console first and then doing it other ways. But that's what I wanted to do today, was through the console. So I'm going to create a function, and we're going to call this, let's see, we'll call it gap dash PowerPoint. Let me do this gap. There we go. And you'll notice that I have a lot of different options here for languages. I mean, a lot of, Go, .NET, Java, Python, Ruby, JavaScript. Pretty nice. So I'm going to go with Python 3.6. And I'm going to leave the default permissions to be open. And I'm going to create my function. By the way, before I create this, they have blueprints where you can have it generate some sample code for very common scenarios. Those are pretty helpful depending on what you're trying to do. They can upload a container image. So if you had a container that you wanted to run in Lambda, you could do that. And they also have an app repository that has some ready-made stuff to help you hit the ground running. But we're going to author from scratch on this one. And I'm going to go ahead and create the function. Okay, my function is created. And you'll notice that it generated my handler, my event handler. And here it's just return the status code and hello from Lambda. I can test this and I'll say, yeah, that's fine for my my event, my fake event. And I test it, and then you'll see hello from Lambda. So that works. That's great. That's, hello world, whatever. But I'm going to upload from my computer my zip file. And this is it right here. And you'll see there's the request module that I included in the zip file. And then here is my Lambda function. So pretty small, but you'll see here that here's my Lambda handler. And what I'm basically doing is calling the call water function. And I'm passing it the body of the JSON payload that is passed in for the event. So from that point, I'm calling the public endpoint and giving it the data that I want to use that's going to be in my payload. So that is the extent of our Lambda. And changes are deployed. So it did that automatically. All right. So now that I have my Lambda, let's create a public endpoint that is going to launch this Lambda. So I'm going to come over here and I'm going to add trigger. And look at my different trigger options. You saw a list of those in the PowerPoint. A lot of different ones here. Pretty cool stuff. AWS IoT, by the way, is a cool one. Here I have an AWS IoT button. You can see right there, and to be able to push this button and launch code in Amazon. It's pretty cool. But we're going to choose API Gateway. And we will, we're going to create an API. It's going to be HTTP, and the security on that is going to be open. So you could access it from your machines if you wanted to. And that's it. So I'm going to say add. And now I have up my API gateway, which is now a trigger for my Lambda. So I have my Lambda code, my API gateway that's going to trigger it. So I'm going to go into the API gateway part. And here you can see that I have a default URL and a route. So Amazon created this for me. But if I look at integrations, I have any. And we want to do this one. We want to add an integration so we can do a post. So let's see here, integrations. We're going to create. Oh, hold on here. And the function. Hold on just a second here. Let me go back, integrations. Yep. Integrations. Create. A route. Hold on. Got to create my route first. I'm sorry. So we're going to create a route. It's going to be a post, and we're going to say, we're going to call it get data, even though it's a post and not appropriate for HTTP, but that's fine for that, for our example here. So I created a route, which is a post, and it's a slash get data. So I'm going to create that. Now, here we go. Now I go to integrations, and for my post, I'm going to attach this to a Lambda function. And there's my function name, gap-PowerPoint, PPT. Create. Okay, so now what we have is our integration through the API gateway. I can do any type access. But more specifically, I can do a post, which is what we're going to do from our client tool with using a slash get data on the end of the URL. So if we go back to APIs, and there is Gap PowerPoint API, and we're going to leave this up because here is my endpoint that we're going to use in our test. Okay, so everything's set up. And we're gonna give this a test here, and hope everybody's still with me. So I'm gonna go to Insomnia. Insomnia is like a postman. It's one of my favorite client tools that I use for REST testing and things like that. But here is a direct call to the internet service, like that first part of the diagram that I showed you what we're gonna do. There is no AWS in this. And you can see that here are the parameters of the call, which it also puts in gray up here, like you would expect. So here's all the things that it's asking for. What is the date, format, units, time zone, station, stuff like that. I'm going to click send, and my response is, you can see that it worked. So this is a straight call to the NOAA service, Rockport, Texas. Here are the values for the water levels that I just asked for. Okay, let's go see what happens on Lambda. So I'm going to toggle back to my URL. Here it is. I'm going to go back over here to Insomnia. I'm going to put this URL in there, and then I'm going to put a suffix on get data, which we said was our route. Okay. Now I did one thing here just to make it easier. Instead of doing all the params like you would do on a get, I made this a post call, which is the route that we created in AWS. And so that means that I'd have to put the JSON body, the JSON data in the body of the request instead of as parameters. So I don't have any parameters. Instead, I have a JSON body. All right, so that is, make sure that matches. It starts with 1 and 7 p.m. And there's 1 and 7 p.m. And there's my get data. And I'm going to click send. And there you go. So there's the headers. There's the response. Notice the response time here is 1303 milliseconds. The response is not as well formatted as the other one, just because I didn't take time to do that. But it worked. So that was the first execution of that Lambda. Now watch what happens when I execute it again. That was 1303. Now we're down to 381. And now we're down to 419. So right around 400 milliseconds now after the first one, 382. So you're going to start seeing performance benefits due to caching and things like that. But that's pretty much it. So we took the call. We had a direct call to NOAA, which you can see in the URL here. Then we took it and we created a route and a public endpoint that did not exist 10 minutes ago. And we told Amazon that when you hit this URL with the post, we want you to execute this Lambda. And this Lambda is going to do something. In our case, it just did the external call to the internet endpoint, public endpoint. So let me go back here, show you one more thing that's kind of cool. We will do this execution of this a couple more times on the Lambda. We just boom, boom, boom. And they have some default logging capability. So if I go back into, I'll go to the main console window and I'll go to Lambda and I will pull up my Gap PowerPoint. And you'll notice here that I have a lot of different options here. Monitor is the one that we'll go to. View logs in CloudWatch. And there's the last logs that were created. I'll click on the latest one and you'll see all of my print statements. And I'm printing out JSON payloads and variable values and stuff like that. All those show up in the logs. So very basic logging, but pretty critical when you're debugging stuff, and it's very difficult to do without you doing some log analysis and stuff like that. So I'm in the logs a lot. They also offer some capabilities where you can stream logs to other more robust solutions like an Elk Stack, Elasticache, Logstash, Kibana, that make it more robust, but you can do that as well. So if I go back to my Lambda, just a quick review of the code so you can see what we did now that we did it. There's my public endpoint call. And there are the parameters that came in through in the body of the Insomnia call. So those values there are the exact same ones that are represented here. That's it. So this is a very basic start, but you can see in literally in 5 minutes, and this is, I have a lot of print statements in here, but 44 lines of code that could have been 24 lines of code. In 5 minutes, we created code that ran on the internet by accessing a public endpoint, which is pretty cool. So I hope you guys are as excited about that as I am. So let's go back here to the PowerPoint deck. Now that we're 30 minutes in, there's plenty more. This was the tip of the iceberg. I get goosebumps thinking about all the features and capabilities that they provided. By the way, it's not just AWS. AWS, I would say, is still the leader, but Azure, Google, IBM all have serverless capabilities that compete with AWS Lambdas. I think the thing that makes Lambda from AWS the best is the different number of the different event integrations and the pure number of them. So, we're the stitchers now of these services that say, when this happens over here, I want to do this. When you have like 45 of those to choose from in one cloud environment and 4 in another, it's not even close. So that's where I think they're winning, is providing more and more really useful event integrations. But the other cloud providers are coming on strong, and they are making up some distance there. We didn't talk about aliases and versions, but really strong capabilities around. I have versions of Lambda. Every time I update it, I can say create a version, and it will give an increment and a number, and then I can associate a version with an alias. So my alias might be test or production, and say my production is the one that's accessed by the endpoint call, and it's accessing version number 17. So you have really safety capabilities in what gets executed by using the aliases and versions. CI/CD pipelines, talked about briefly at the start. There is no real limitation there compared to the ones that we're used to. It's also very robust, and so yeah, you should use Lambdas with CI/CD. Event handlers, sky's the limit there. Just a pure number of them. Really cool things to do. You know, here this IoT button from AWS. To think that when I push this button, it'll launch a Lambda. The hard part to think about is, what do you want to do when you push this button? You know, maybe you do something where, you know, like you text for help, or an old person wears it in the house and it's like it's a SOS button. Or maybe it's like, hey, I need to order more beer every time I push the button. I don't know. That's the hard part. The easy part is in 5 minutes, you can have it wired up and doing cool stuff. So the sky's the limit, and there's a lot to it. And I hope everybody takes a strong interest in getting better about it. Finally, I want to mention the serverless challenge. I hope everybody knows about this. The deadline's October 22nd. But for those of you who don't, GAP challenges you to create your own serverless function, either in AWS or Azure. The function can be as simple as a calculation based on the input, or as complex as you like. The important part is to get started in the serverless world. And so I think that one of the reasons that we are doing this serverless challenge is to help augment the skill acquisition in this particular area. I know that when I advise clients myself, after listening to what they're trying to do, I am a huge proponent of a serverless first approach. And that is, unless it won't work because of the number of executions or because of the type of workload, it's just not a good candidate. Serverless first. And I think the more that we can claim to be experts in that area as having strong development skills and experience in building serverless applications, I think it's only going to help us. So that's why I'm passionate about it. And I hope everyone here is as well. Questions?
My question was, how do you keep this code up to date? Can you integrate it with GitHub or something?
Yes. You would integrate it with your GitHub, or whether or not you're using one of the cloud providers, like AWS has code commit, things like that. But that pipeline and that flow would be what you would make. And so that way you could keep it up to date in multiple environments.
Thank you.
Okay. Dave, quick question. For me, this is something like pretty new. I read quite some, but I want to do this like the example you just did. And just quick question regarding the account in Amazon. In cases where we actually want to have like a public endpoint and all of that, like what's like the type of account we need to create? Do we have to pay something for this testing? How can we start with this, like to start making this type of exercises?
Well, I see, first of all, David Alvarez is on the line. He controls that part of it. You don't have individual accounts. You get access to one of the GAP accounts. But as far as, hey, can I get access to have, a playground and to test some things? And absolutely, right? And unless you're doing some things around big data, some more costly features, like I could have put that in a loop and executed 1 million times, and I think it'd be like 25 cents. So we monitor the billing of that. We have a budget for that. So for anyone that wants access to AWS that does not have that today, please reach out to David Alvarez. David, you want to say anything here?
Yeah, well, there are two things over here. So one, if they are applying for the challenge, the gap challenge of this serverless environment, they can in fact they can request through labs, because I think Eduardo is the one that is creating the accounts for the challenge. So if you're going to participate on that challenge, reach out to Eduardo, and then if it's for something else that you want to have access for, for implementing a new solution for a POC or whatever, you want to try it on for AWS or Azure, just reach out and I will help you to get the proper authentications and credentials to start working on this.
Okay, perfect. Thank you very much.
It's also worth to mention that in the free tier of AWS, if you have your own account, you have 1 million free requests per month. So you can build many things for free.
Yeah.
That's also a valid thing to mention. If you want to create your own account, I mean, the first thing the AWS is going to request you is a credit card, but don't be afraid about that. If you're going to get a 1 year free tier of using AWS, and in the case of Azure, I can't recall what's the free tier that they offer, but they also offer one. And if it's the case for GCP as well, they offer something for free as well. So don't be afraid. If you want to try things out for your own, I mean, you want to create your own account, go ahead and do it. That's not going to be also a problem.
Okay, nice, perfect. Thank you.
Hi, Dave.
Hey.
Hey, it's Jose here. I just have a question. I'm really new in this serverless world. I pretty much know nothing. So I have a question regarding, let's say, for example, I have a server, localhost, that's the name of the server, that allows me to create an API with Flask, and I can consume it or do whatever I want. What exactly then will be the difference between having like this, which is a server approach, this is a server and I can create my API, versus creating this Lambda function?
Well, there's a few, Jose. One is that you are going to be managing that server that's running your Python app that has the Flask stuff, that has the endpoints. So there's that. The second is with Lambda, there's nothing for you to do. The Amazon team is managing that stuff for you. The second is as things grow and you need to either beef up that machine or create multiple machines, and that complexity with routing, none of that is an issue in Lambda, because I can have thousands or tens of thousands of these that are independently scalable. And that are not bound by a single server that is my responsibility to manage. So if I were you, I can't think of a good reason to have Python web app server to be sitting on an EC2 instance to service requests instead of just running Lambdas.
Okay, yeah. Thank you, Dave.
But just because I can't think of one doesn't mean there isn't one. So if you do come up with a good reason, let me know. But for simplicity and manageability and performance and scalability and all those things, it's no question. You go with the serverless route. Our customers, I'll throw this in there. Our customers, and prior to joining Gap when I was at IBM, similar, where they are struggling with containers and the complexity around container management and orchestration with Kubernetes. And so this serverless movement has come on strong as an alternative to that they're kind of freaking out a little bit, because there's a lot of vendors that have a lot on the line, whether or not it's Google with the Kubernetes implementations, or Red Hat with OpenShift, or IBM with their container management solutions. So that world is kind of in jeopardy right now, because the cloud providers said, we're going to make this easier for everybody because you're all struggling with it. Just worry about your app, and we'll manage all the hard complexities around that. So that's one of the reasons that people are getting the benefits from that, mainly around speed of delivery and simplicity in building these things. And like that one you saw in the UI, if you have your container and you just say, hey, I already have it containerized, just run my app, you can upload your container image. So it's really, they're making it so easy for you to do it any way you want to do it, which is pretty powerful. What else, everybody? Was it useful? Did I spark some kind of interest that, hey, I need to learn more about this, or this is a powerful thing that I can see our customers using more and more of, and I'm anxious to get started. Hopefully that's the case.
I actually do have another question, Dave.
Sure.
I actually find it very useful, but I would like to, it's kind of two questions in one. It's, with this, what is your expectation from the Gapsters to the serverless world? What would you like to see us doing? I know that this could be very important for clients, like in my current client, they are migrating to Azure. So a lot of the developers actually, with this knowledge, can help the client with. But do you think there could be another applications inside of Gap? For example, I am a QA, so I'm not sure if I will be able to be that helpful because in QA perspective, I don't know how will I help the client with this. It will be more like a developer thing. So I inside in Gap, if I try to learn serverless and all of these things, how can I be able to help Gap in any other areas?
Yep. So the first question, the more we can claim to be like strong experts in serverless, I know when I'm having these modernization meetings with customers, I am touting that, right? So one of the things I want to try to get us to a place is that we can back it up. That, okay, Dave, you recommended a serverless first approach. I'm ready to go with the Gap team. And then I don't want to have to go through and say, okay, do we have anybody that knows serverless, right? So I want to make sure that we are in concert together with the things that customers need and our ability to satisfy those based on strong skills in those areas, serverless being one of the main ones. DevOps would be another for instance. Second, on your QA question, I think that there would be an opportunity for QA to think about what are some QA approaches to testing serverless applications. I think there's a strong niche there that is undefined, that people are so used to not testing things that are built that way. So what are the differences in QA a serverless application? That would be a great title for a white paper that would probably get a lot of circulation given the popularity of serverless these days. So I don't have an answer to that. I personally don't have a QA background, but I would be very interested in what are the differences from a QA perspective on serverless testing.
Okay, thank you.
All right. Does anyone have anything else? And if you don't, please feel free to reach out to me anytime. Email, Slack, whatever. Very passionate topic of mine, and I'm here to help. So whatever I can do to help any of you, please don't hesitate to reach out to me.